Today we're still on ellipses and finding equations. So today I have a few more examples to show you, so slightly different. So what is the difference? So it's still a-2. Remember I showed you, okay, so ellipses equation is like this. A squared, b squared, it's equal to 1. Could be other way around, like x and y would stay the same. A and b switches, so it depends on major, minor axes, so a and b switches. Okay, so what happens is, just because x squared and y squared is nothing added to it, so once you graph, so what happens is, the center of, I would say center, it's not exactly the center point. So basically when I say center, it's basically the intersection of the major and minor axes. So center point for these type of problems is always 0 and 0. That's the reason there was no number added or subtracted to x and y. So today is the same concept, but I'm going to show you what h and k means. Basically it's going to be a shifted ellipse. All right, so shifted one. So I would say translated graphs. Okay, so your equation for these translated ones, it's just going to have h and k in the equation, and the rest of the stuff still the same. A is always the bigger number. A goes under major axis variable. So the rest of the stuff, even the equation, everything is the same. So now the equation, the only thing that's different is h and k. So your equation is going to look something like this. Something like this. So the only thing that's new for you guys, I would say, is this h and k. So again, I repeat, this h and k is nothing else than just the center point. I would just call it center point, even though it's not exactly the center point, but it's still kind of intersection of those two x's. How do we deal with this? So let me show you first example. So let's say I have x plus 3 square 25. I have y plus 2 square over 4, and it's equal to 1. Okay, first few steps still the same. You need to figure out major and minor axis. Okay, so major axis definitely going to be x-axis this time. Why? Because the bigger number is under x. So I know once I plot, so this ellipse definitely going to be stretched more on the x-axis. Okay, so I'm just going to label this as a squared, this is b squared, which is the minor axis. What would be your a value? Remember, this is a squared, so a value would be square root of that number. So this is 5. B is 2. I hope you understand so far. Now, let's try finding center point, which is a and h and k in this equation. What is that in this equation? Remember, we take opposite, so your h and k. H is something that goes with x, and k is something that goes with y variable. So h and k is -3 and -2. For this example, I'm going to show you this problem like 2 different ways, and whichever way you think it's easier, just apply that. All right. Anyways, so how do we find, because my question is to find me vertices, co-vertices for this one. How do we do that? So one thing you could do, let's learn about graphing first. So for graphing, for sketching, first thing what we do is, what we need is h and k. Let's plot that. So h and k, so it's -3. Let me have a grid here. It would be easier. So let's just erase this and let's have a grid. So I know there's a way we can do that. Gotcha. Here you go. I'll do this one. That's better. Here you go. So let's say this is, or wait a second. Okay, that's better. That's my graph. So my center point is at -3 and -2. Let's go by 2s. -3 and -2. This is the center point. Okay, now I need to find my vertices. So since I already know my major axis is the x-axis, so the bigger one definitely going to be horizontally like this. But how many? What's going to be the end point? How do we do that? So back to this equation. On the x-axis, we're going by 5 both sides. So you need to travel 5 units from this point. So 5 units right and left. We're going by 2s. So 1, 2, 3, 4, 5. So that's my first vertices. And on the other side, 1, 2, 3, 4, 5. This one here. And literally you can count. So if I ask you to label this point would be, I have 2 and -2. And this one is -8 and -2. Guys with me so far? I hope. Yeah. If not, then please, you can pause the video and you can go back. So we are not starting from 0, 0 this time. The center is h and k, which is different than 0, 0. So it's easier if you plot it first. Okay, other one. On co-vertices, which is my y-axis, we are going by 2 units top and bottom. So from this point, let's pick a different color. From this point, you got to go 2 units up and down. We're going by 2s here. So each box is 2 units. So 1 and 2, this is going to be my first co-vertices. Other one would be, here you go. And let's label. So this is going to be -3 and -4. -3 and 0. And for graphing, I will just connect these points. And that's going to be my ellipse. There you go. That's one way to figure out those vertices and co-vertices coordinate points. But there's another way. Okay, so for that, you can make a table. Let's say in the book, if I asked you to graph, yeah, I would certainly follow this method. But let's say they just asked you to find co-vertices and vertices. This is something we could do. This is another way. We can make a table. How? Let me just, I need to, oh gosh, I don't want to erase the whole thing. So let's just say this line goes all the way here. Okay, for the table, how do we do that? What I want you to do is, I want you to make 2 columns. This is for vertices, and this is for co-vertices. And first, I just want you to put h and k. H and k in the middle. H and k is -3 and -3 and -2. Now, try understanding. Again, trust me, this table is way easier than graphing. So try understanding the process. Now, this is what I want to say. So if I have to find my vertices, just a second, I drew the wrong one here. Just a second. Because this line was here. Not there. My bad. Yeah, that's better. Okay. Okay, now if I have to find my vertices, so what happens? Try understanding the pattern. If I have to find these points, and those 2 points are moving on the x-axis. When a point moves on the x-axis, x changes and y stays the same. I hope you understand. You're going like x numbers changes, but y stays the same. And you're going 5 units sideways. So if I have to find the number on the right side, how about if I add 5? And if I have to find the number on the left side, I would subtract 5. And I know my y number would stay the same. So what would be the right side number? So -3 added 5, it's 2, and -2, that's going to be my right side vertices. And on the other side, -3, -5 is -8. That's going to be this vertices. So same rule applies for the co-vertices part. So now, I'm looking for my y-axis point. Now, y would change and x stays the same. So I would keep my x numbers the same. Okay, if I have to find the number that's above this center point, so I would add the distance. So add the distance. And if I have to find the point under, I would subtract the difference. So -2 minus 2, so the bottom co-vertices would be this. And -3, 0 would be the top one, which is here. Here you go. So that's what you could do. Again, table, if it literally asks you to graph, yeah, make sure you graph it. But if it asks you to find just vertices, co-vertices, that could be another way to do it. Anyways, I'm going to show you a few more examples, and then I hope that would make more sense to you. So let's say, I know today's lesson is going to be a little bit longer than normal ones. I have x plus 2 square, 9. Y minus 5 square over 49, and it's equal to 1. Okay, this time I'm not graphing. I'm just going to solve for vertices, foci, and center point. What's the center point? So center point, h and k. What is that? It's -2 and +5. Okay, which one is the major axis? Y. Y is the major axis. Why? Because the bigger number is under that. So what's your a value? Remember, first thing I would solve for a and b. What's your A value? A would be 7. What's B value? It's going to be 3. I'm going to make a table. So let's say if I'm looking for vertices, co-vertices, and I'll even do foci for you. So first thing, I would put center point in the middle. If I have to find vertices is going to be on the major axis. Major axis is Y. So it means if it's on the Y would change. X stays the same. So I would add 7 and subtract 7. So if I add 7, that would be the number above the center point, and the X would stay the same. So 5 added to 7, 12 would be my first vertices. On the other side, 5 minus 7, negative 7, that's going to be negative 2. That's going to be my second vertices. Okay, how about co-vertices? Co-vertices, oh, my bad. Co-vertices is on the x-axis. So now x would change, y stays the same. So I'm just going to put y right away. So how many units you travel on the y-axis? I'm sorry, on the x-axis, we're going by 3 units. So it means I would add, well, I'll do it here. I would add 3 down here to get the number on the right side. I would subtract 3 here to get number on the left side. So the number on the right side would be 1 and 5. One number on the left side would be negative 5 and 5. So last thing, I need to find foci. But foci, you have to have the C distance. How do we find C distance? So that's where you have to use the C equation first. So find the C number. What is that? So C squared is missing. A, do we know the A number? What is that? 49. B is 9. Add these two. Oh, my bad. It's not plus, remember? It's opposite sign here. So it's minus here. It would be 40. So C is equal to square root of 40. Or I would say, I don't know if you want to say 6 point something. It's pretty much estimated 6 point. Let's just say 5 just for the sake of calculation. For foci. Foci is always on the major axis, right? So which one is my major axis? Major is Y. So now, the Y number would change, not the X. So it's going to be on the y-axis. So y number would change and x would stay the same. So how many units you're traveling for foci? So 6.5. So number above, I would add 6.5 here. Number under, I would subtract 6.5. So if I add 5 to that, it's 11.5. If I subtract, that's going to be negative 1.5. Here you go. So that's going to be your answer at the end. So I hope you understand. So yeah, I guess for today, this is all. And then tomorrow we have one more example like this. And I guess, yeah, we are almost there to finish ellipses here. So thank you for watching. Stay safe and bye-bye.